today I've got a question for you. A question that I get a lot. Why should I invest for my team to test models for bias in their data or machine learning models? And I kind of get it, because the argument is models are getting smarter. We've got a lot of guardrails. We've got red teaming. We've got reinforcement learning with human feedback, or whatever mechanism to make sure these things are safe. And they're getting very, very smart by the time we get to interact with said model. And so I'm gonna try to explain why it's still important. I'm gonna use an analogy, because I love telling stories, as you have noticed in my previous videos. And so here we go. So I was thinking about a great analogy, and I went back to my childhood. So I had moved from the UK to West Africa, Ghana, for part of my childhood. And I would go to the farm with my grandfather, and we would pick mangoes. And frankly, that was a lesson in observation, because I would notice that mangoes in Ghana were often green, at least the ones that we planted, when they were ripe, much like the unripe mangoes that you would find anywhere else in the world that are normally yellow or red or whatever. So this poses a unique challenge, right? How do you tell when a mango is truly ready to eat? Because when it's unripe, it's green, at least when I was growing up. And when it was ripe, it was also green, right? So let's consider this image of a mango. How do you truly define a ripe mango? We're gonna explore how our experiences shape our perceptions and how this relates to bias in machine learning today, okay? So when I ask you to describe this mango, just by sight, you may use descriptors such as green mango or immature, or you might say, go with texture. You might say it's firm. You might have assumed that it was unripe until I cut it open. Now, what if then I show you a red or yellow mango? However, we may still use words like plump or ripe or mature, but because you saw that green mango is actually ripe, you may actually think to disassociate color with our initial descriptor, with the way we describe it. So now you follow where I'm going with this. Our initial reaction is based on our personal experiences. If you've only seen yellow mangoes as ripe, you'd make the same mistake that I was struggling with as a kid. As a matter of fact, in many cultures, green is associated with unripe fruit. If you're French or Spanish speaker, you may refer to a mango as mango verde. Our personal experiences can lead to biases, right? So that's the first tranche of what I want to say. Now, bias originates in the data that we use to train AI models. The algorithms transmit it and even amplify those biases. Users are exposed to skewed outcomes that can cause real-world harm, and we users actually perpetuate those biases. And those biased outcomes and interactions generate more biased data, perpetuating that sort of vicious cycle, right? In other words, AI systems trained on limited biased data sets fail to accurately recognize or process deviations from those narrow norms. And just like how we might misjudge a mango's ripeness solely on its color, a machine learning model can grossly misinterpret critical information when their training data does not reflect diverse and complex real world, like what we experience in the real world. So now that we have understood the root of bias, let's explore the techniques of bias testing. I have a Udacity course launching soon that is gonna walk you through how to use Deep Eval by a company called Confident AI. It's an open source library, which is Deep Eval is like a comprehensive testing platform developed by them to evaluate the performance of fairness in AI models. And in that course, I sort of walk you through geographical bias statistics and testing. So you use like a test case like you do, and if you're familiar with software testing, to test for that. We can also, not just geographical bias in the case of a mango, for example, but you can sort of test for gender, race, religion. Remember, most of the time, a typical enterprise may not have the resources of a Google or Microsoft OpenAI. We build off of their model. So I often hear this misjudged. We think we're evaluating models, but we're actually not. We're actually evaluating the systems that power these models. detection, robustness evaluation on that course. So definitely look out for that. And we'll go through mitigation strategies, balancing your data sets, and debiasing techniques, that kind of stuff. All right, so I can't wait for you guys to try it. It's going to be part of the AI Product Manager Nano degree, but part of it is going to launch first, and the full Nano degree is going to fall over. So stay tuned, and I can't wait to see what you have to say about it. Comment, subscribe if you want to see more of this, and thank you.